What is going on, guys? My name is Amos and I'm back again with another video. So in today's video we want to carry out an investigation. What value must the base of the logarithm be? Alright, so this question is very important as it helps us understand what we are doing. Alright, let's start by giving ourselves some logarithmic equation. Alright, now let's say x is equal to the logarithm of y, the base b. Alright, well, this is equivalent to saying that b to the power x is going to be equal to y. Alright, now let me ask you guys the first question. Can the base of the logarithm be 0? Well, can the base be 0? Let's carry out an investigation. Well, what would it mean if the base was 0? Alright, let's say we had some logarithm and alright, where the base was 0. Well, what does that mean? Well, this means, so if b is equal to 0, what is going to happen? Then you're going to have that 0 to the power of x is going to be equal to y. Alright, now for simplicity, let's say x and y, alright, x and y are real numbers, are positive real numbers for simplicity. And let's see what is going to happen. X and y are positive real numbers. Alright, now for simplicity you can think of this as 1. X is 1, and let's say, suppose, alright, let's suppose that x is equal to y is equal to 1. Well, because we know that 1 is a real number and we just want to see what is happening here. So we have 0 to the power of 1, basically 0 to the power of 1 is equal to 1. Well, is this equation true? Well, totally. Is this equation true? Well, this is going to be totally false. This is going to be totally false because any number raised to the power of, let's begin simple here. Any number raised to the power of 0 except 0, alright, is 1. Any number raised to the power of 0 except 0 is 1. So there is no way of equaling this 1. If we raise 0 to any power, basically we'll get 0. So there is no way that we're going to have a 1 here. So this equation is false. Now, if you think I'm messing with you guys, well, you can choose another value of x. You can choose 2, for example. Or you can choose 2. Alright, so you're going to have here 2, and you're going to have a 2 here. So same problem. This is false. So this is false. So the base of the logarithm cannot be 0 because we're going to have some form of an we're going to have some inconsistent results. All right, so the base of the logarithm cannot be 0 because when we translate that logarithmic equation into an exponential equation, well, we basically cannot see anything happening here. So the equation that we are getting here is false. All right, so this is false. So there is no value of x to which I'm going to raise the 0 for me to equal y. Such a thing cannot happen. So the base of the logarithm cannot be 0. Well, can the base of the logarithm be 1? Alright. Now, can the base of the logarithm be 1? Well, let's try that out. So if b is equal to 1, what does that mean? Then we have that 1 to the power of x is going to be equal to y. And now let's say x and y are positive. For simplicity again, x and y are positive real numbers, So what is going to happen? And then here we want to suppose that x is equal to y is equal to 1. So basically what we have is 1 to the power of 1 is equal to wait here. We want to take y is equal to 1, for example. Let's say y is equal to 1. Now x can be anything. So this is actually going to be easier to understand this way because that's the best way it can be explained. So let's take y as 1 and we let x be anything. Let x be anything and let y be equal to 1. And now generally x and y are positive real numbers. So we have 1 to the power of x is equal to y. Now y is 1, so I'm going to put my 1 here, right? Notice that any value of x for any value of x, the equation is always true. For all values of x. For all values of x. Now what are we saying here? X and y are positive real numbers. Now for all values of x in this domain, of course now we are focusing on simplicity. We don't want to worry about complicated stuff. So for all values of x here, in the domain that we've chosen, for all values of x in the domain that we've chosen, alright? Notice that the equation is always true. Well, if x is 0, if the power is 0, 1 to the power of 0 is 1. Any number raised to the power of 0 is 1 except 0. So the equation is true. Now for x equal to 1, the equation is still true. 1 raised to the power, 1 raised to anything is always 1. So the equation is always true. Now for all values of x taken in this domain of positive real numbers, we have that the equation has no unique solution. Alright? The equation has no unique solution. No unique solution. So now this is also worrying because we want to have our equations having unique solutions. Alright, now let's say y is greater than or equal to 2. What is going to happen? Notice what is going to happen, you guys. So for all values of x, for now we see that for all values of x taken in the domain of positive real numbers, the equation has no unique solution. Now what if y is greater than or equal to 2? What is going to happen? Alright, let's suppose that y is greater than or equal to 2. So basically we're going to have 1 to the power of x is equal to, or y is greater than or equal to 2. So I can just put 2 here, you can put a 3, you can put a 4, all that good stuff. And right, so we have 1 to the power of x, 1 to the power of x is going to be equal to 2. Well, is this true? Now for all values of x, the equation is always false, because 1 to the power 1 raised to the power any number is always going to be 1. So this equation is false. So for all values of x taken in the domain of the positive real numbers, remember here, this is where we're taking our x and y, the positive real numbers. So for all values of x taken in this domain, we have that the equation is false. Alright, the equation is false. It's never going to work. The equation is false. Now look at the inconsistency that we have here. So if y is 1, well, we have no unique solution. If y is greater than or equal to 2, well, basically we don't have a solution to the equation. So again, the base cannot be 1 because of this undefined behavior. Alright, so now can the base of the logarithm be a decimal point number? I know you guys have this question in mind right now. So can the base of the logarithm be a decimal point positive real number? Of course, yes, it is. It can be a positive. It can be a decimal point positive real number. Now, if you guys are lost, let's look at the natural log of 2, for example. What is the natural log of 2? Well, this is equivalent to saying we are taking the logarithm to the base e of 2. Now, what is e? E is a constant. E is a constant which is approximately a constant that is equal to, all right, now we all know that e is a constant that is approximately equal to 2.718. Of course, this is taken to 4 significant figures. So this is what you have. So the base can be a decimal point positive real number. Or can the base of the logarithm be negative? Well, if the base of the logarithm is negative, we are going to get complex or imaginary solutions. All right, we're going to get complex or imaginary solutions. So for the purpose of this introductory video, we're going to say that the base of the logarithm is going to be a positive real number, and that is all. That is going to get rid of all the inconsistent results and all the things that are drawing us back. All right, so now as a bonus, some bonus information. What value must y be? Well, can y be negative? Can y be positive? Well, again, y has to be a positive real number. And now you can always translate your logarithmic equation into an exponential equation and see what is happening. All right. So y, of course, has to also be a positive real number. And that is all for this video, guys. I'll see you in the next one. Be sure to subscribe and give us a like if you like the video.